Basic copper carbonate is a green solid that occurs in nature as the mineral malachite. It has been used historically as a pigment called green verdure. It's also used to remove tiles and nitrogen sulfide from some gas streams, as an accesite, wood preservative, and also as a precursor to various catalysts and copper soaps. In my case, I'm gonna use it in the future to make pyridine. I know, I'm just a copycat. Anyways, I start by making two solutions. The first solution is made dissolving a copper 2 salt, usually copper 2 sulfate pentahydrate or copper 2 chloride. In my case, I use copper 2 sulfate pentahydrate because I already bought a kilo some time ago for a past video. I start by dissolving 150 grams in a 1-liter beaker with roughly 400 ml of distilled water. Even though copper 2 sulfate dissolves pretty well in water, this big amount won't easily at room temperature, so I heat it up in an electric stove. The other solution is a saturated sodium carbonate solution. Sodium bicarbonate can also be used, but the amount of CO2 gas released is more, so it's more convenient to use sodium carbonate instead. Either way, it's pretty easy to make, like I shown in a past video I recommend you watching. I use a 600 ml beaker to make it. I was a bit scared it would break because it was already cracked from the bottom, as you can see. It cracked when I was making more sodium carbonate for this project and wasn't cautious enough and got it out of the electric stove too soon. However, since I didn't have any other one, I used it anyways. I dissolved around 63 grams in around 150 ml of distilled water. An exothermic reaction takes place here and the solution starts heating up a little, but wasn't a real big deal. I then transferred it to the electric stove too, and started to heat up both solutions and occasionally managed to stir both of them till everything dissolved. The copper sulfate dissolved quickly, giving this cool dark blue color. However, the sodium carbonate didn't. I added some more water until having around 200 ml and stirred. It eventually dissolved till having a colorized solution. I then turned the heating off and started adding the sodium carbonate solution to the copper sulfate one slowly and in different portions to avoid overflowing. See, what is happening here is copper sulfate reacts with sodium carbonate to form basic copper carbonate. It starts precipitating due to its insolubility in water, as you may see, and it also makes CO2 gas, which starts bubbling out. If the sodium carbonate solution is added all at once, it will start foaming a lot till an overflow. I then started stirring around with a glass rod and the solution turned to a light blue. I waited till the foam came down and every time it happened added some more solution, till everything was added. At a certain point I added a lot of the solution at once and started foaming to the top and almost overflowed. Thankfully it didn't happen and I can continue normally with the project. When all the carbonate solution was finally added, I then let it precipitate. As you can see, it immediately started precipitating, leaving the water with a dark blue color. However, I let it precipitate overnight. The next day, everything already precipitated, leaving the water colorless. I then proceeded to filter everything through a filter paper, and this is where the nightmare began. This because I didn't have the materials needed to do a vacuum filtration, so I had to do a primitive one instead, and as anyone would expect, it took forever to fully accomplish and required many filter papers and coffee filters. So, to make it simple, I'm gonna sum it up in a scheme. I started by filtering the entirely 600 ml of solution and precipitate to a beaker. However, to make the process faster, I started filtering the other half to an aluminum flask simultaneously. It got to a point in which seemed nothing was coming through anymore, so I took them out and started filtering the rest of the solution to a coffee filter. I then washed the beaker 4 times with some distilled water. When nothing came through anymore, I put the coffee filter and the rest of filter papers in some aluminum foil to let them sun dry. However, I filtered all the solution left again because it seemed some product did come through. Uh, Sadly, I ruined it and had to do it again. When the beaker got full of liquid, I changed it to an aluminum flask to continue filtration. When the filtration was finally over, I took the coffee filter and added it to the aluminum foil with the rest. I ended up having around 500 ml of slightly blue water. The aluminum foil containing the filter papers and coffee filters was then transferred to an empty pizza box to avoid any external contamination, and was left to dry. 2 days later, I found most of the liquid leaked from the beaker and made a whole mess, so I finally had to let it go and retire the beaker. The solid product had some white crystals on the surface, which indicates some sodium carbonate didn't react and it's contaminating the product, so I had to remove it. To do it, I first scraped everything with a spatula to a brand new beaker and then started heating the beaker and added 350 ml of water to dissolve the sodium carbonate crystals. However, I then added a little more water to having 400 ml of the solution and then manually stirred with a glass rod to mix everything. I then turned the heating off and let it precipitate over an hour. An hour later, it precipitated entirely. See how the liquid is now white? This is due to the sodium carbonate dissolved in the water. I then filtered it all again. This time I tried pouring only the water first and then the solid to carry out the filtration faster. It took some time, but I eventually made it. I then washed the beaker 2 times with some distilled water. When it seemed nothing was coming through anymore, I then took the filter paper out. I ended up having around 300 ml of a sodium carbonate solution which I just threw away. I then scraped all the product back into the beaker with a spatula. To try faster, I got the brilliant idea to place the beaker on the electric stove and started heating it up. According to Google, the temperature in which basic copper carbonate decomposes to copper oxide is around 290 C, so I thought heating it up shouldn't be a problem. But I was completely wrong. Around 60 C, I noticed it started bubbling, even though it wouldn't make sense. I thought it was just water bubbling out, until I realized that a black layer was forming at the bottom of the beaker, so I took it out. The bubbling was instead CO2 gas, which is formed as a byproduct of the thermal decomposition of basic copper carbonate. So instead, I let it sun dry for a few days. 6 days later, I got left this green powder. This is our basic copper carbonate. I then transferred it to a watch glass to measure the yield and also because it looks cool. It turned out to be 93.24 grams, which represents a yield of 140%, so it was probably still wet. Another important aspect is the cleansing of the materials. Water cannot be used since basic carbonate is insoluble. Instead, an acid gotta be used. In my case, I use muriatic acid to clean everything. What's happening here is actually not a reaction in which basic copper carbonate and muriatic acid react to form copper chloride, CO2 gas, and water. You can see here its characteristic green color. Either way, I hope you liked this video, and see you in the next one. Bye!